Wait a second. So, good morning, everyone. So, let me share the session. We'll join then. Quickly, I will share the session, then we'll continue our class. Okay, we'll start. First question on your screen. First question on your screen will start. Okay. So, surface tension is due to. CT is giving the answer cohesion. Surface tension is due to. So, this is your new platform resultant. Okay, providing coaching for GATE ESC state EEG examinations. Okay, so what should be the answer for this question? So, so surface tension is due to. Is this cohesion and adhesion? Is this cohesion only or adhesion? Yasmin is saying B. So this surface tension is due to cohesion only. Remember that. Okay, cohesion only. Everyone. Surface tension is due to cohesion only. Absolutely correct. Okay. Sir, what is the surface tension? Surface tension is simply we can define the surface tension denoted by sigma. That is the force per unit length. Force per unit length, or it is the energy or work done, energy or energy per unit area. Per unit area. Absolutely correct. Okay. Next question. Next question on your screen. Next question. Next question on your screen. So it is for a fluid in motion. It is for a fluid in motion. Pressure at a point is same in all the directions. Then the fluid is called as. Billy is saying standard questions. आ जाओ. Okay, okay. Okay, standard questions भी लाएंगे. कोई बात नहीं. So we'll provide standard questions also. We'll provide standard questions also. बिल्कुल. It is the starting of new channel. So हमें यहाँ पे करना पड़ेगा. चलिए जी इसका मार्क कीजिए आंसर. So for a fluid in motion, if we have a fluid in motion, okay, absolutely correct. Then then at a point, pressure is same in all the direction. Then the fluid is what? A real fluid, a Newtonian fluid, an ideal fluid, a non-Newtonian fluid. So this is the Pascal law, okay? This is the Pascal law, absolutely correct. Pascal law. So Pascal law is valid in case of the ideal fluid, okay? Ideal fluid. So what should be the answer? What should be the answer? The answer should be C, okay? Answer should be C. Next question on your screen. Next question on your screen. So the unit of surface tensions are unit of surface tensions are what is the unit of surface tension? What is the unit of surface tension? What is the unit of surface tension? Anyone? Billy, Yasmin, everyone. What is the unit of surface tension? So what is surface tension? What is surface tension? Surface tension is defined as force per unit length. Okay, if we define the surface tension, it is denoted by sigma, and that is force per unit length. Absolutely correct, sir. Force per unit length. So it should be Newton per meter. Okay, Newton per meter. So there is no answer of Newton per meter or force per meter. So we can say that the sigma is also, that is surface tension, is also defined as energy per unit area. Energy per unit area, or it is also denoted as work done per unit area. Work done per unit area. Okay, this is another definition. So your sigma can be written as energy per unit area. So what should be the answer then? Your answer should be B. Okay, your answer should be B. So the answer should be B. Okay, answer should be B. So it's energy. Adnan is giving absolutely right answer. Energy per unit area. Next question on your screen. Next question on your screen. Next question on your screen. So first we'll complete the fluid mechanics. We'll complete the fluid mechanics, and then after we'll go with the RCC. Then we'll go with the RCC. Okay. So the question says here, when a fluid rotates at constant angular velocity, it is a constant angular velocity. Absolutely correct, sir. About the vertical axis of the rigid body, then the pressure varies as. What is the pressure? Okay, what is the variation of the pressure with the radial distance? Adnan is saying C is the answer. Adnan is saying C is the answer. Anyone? Shabnam is saying B is the answer. Okay. So the pressure varies as, remember, always the pressure varies in case of the constant angular velocity. That is the that is this is the free vertex motion. In case of the free vertex motion, the pressure varies as inversely proportional to 1 by r square. Okay, it is inversely proportional to 1 by r square. Okay, absolutely correct. The pressure varies as inversely proportional to 1 by r square. That is the radial distance. Absolutely correct. So your answer should be A. And if we are talking about the force in case of constant angular velocity about the vertical axis rigid body, okay, so in that case force will be directly proportional to 1 by r power 4. So the force will vary as 1 by r power 4, and the pressure will vary as 1 by r square. Absolutely correct. Okay, absolutely correct. Next question on your screen. So A should be the answer. Next question on your screen. Next question. Okay, believe saying सर एक क्वेश्चन है. हाँ इनवर्स दिया है. हाँ वेरी करेगा स्क्वायर. हाँ square of the radial distance. हाँ I'm wrong here. It is pressure is directly proportional to r square. Absolutely correct. R square. Pressure is directly proportional to r square, and the pressure and the force is directly proportional to r power 4. Absolutely correct. Okay, so it is I'm wrong here. Okay, so the pressure is directly proportional to r square, and the force is directly proportional to r power 4. Okay, so next question. Next question. Okay, absolutely correct, Shabnam. Absolutely correct. Okay. So at constant temperature, we have a constant temperature. The fluid whose velocity does not change with the rate of deformation. So in that case, the fluid will be called as Adnan. In that case, the fluid will be called as Adnan is saying Newtonian fluid. Okay, I'll explain the last question also. I will explain your last question also. Don't worry. So what should be the answer? Adnan is saying D is the answer. Anyone else? So we have a constant temperature, the fluid whose viscosity, remember mu is constant. Sir, mu is constant. In that case, okay, mu is constant. Sir, that fluid will be called as Newtonian fluid. Okay. So if we are constructing the graph of this fluid, so on the y-axis we are marking the shear stress, and on the x-axis we are marking the velocity gradient. du by dy. Okay, du by dy. And in case of y-axis, we are marking shear stress. Okay, the shear stress equation tau is simply, sir, given as, okay, it is mu du by dy, du by dy, okay, du by dy whole square, sorry, whole power n plus b, okay, plus b. Remember, in case of the Newtonian fluid, your b is 0, your b is 0, and your n is 1, and n is 1. Absolutely correct, sir. Okay, n is 1. Now when n is 1 and b is 0, okay, when n is 1, b is 0, so your shear stress tau will be equal to mu du by dy, mu du by dy. Sir, what is the equation? Okay, what is the equation? Tau is equal to y is equal to mx, y is equal to mx. Sir, this is straight line equation, this is straight line equation. So the graph will be the straight line, and slope will be m, that is constant. Here m denotes mu, viscosity. Okay, viscosity is constant, so you can go with d. Okay, you can go with d. ओके, कोई बात नहीं है, कोई बात नहीं है। चलो इसको रिवाइज करके रखना, रोज एक एक प्रैक्टिस सेशन आएगा, ठीक है, कोई बात नहीं। नेक्स्ट क्वेश्चन, नेक्स्ट क्वेश्चन ऑन योर स्क्रीन। तो बिलीव सेइंग बाउंड्री लेयर क्या है? इफ द प्लेट इज हेल्ड parallel to the fluid, total drag is due to. Okay, 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 I'll mark your question, don't worry. I'll mark your question. Adnan is saying B is the answer. Okay, Adnan is saying answer is B. Anyone else? Anyone else? Anyone else? Remember, numericals will be after 10 or 10 or 15 question. After 10 or 15 question, there will be a lot of numericals. Okay. What is the answer? What is the answer for this question? The unit of viscosity, or the unit of viscosity, or what is the unit of viscosity? What is the unit of viscosity? Okay. So I'll completely discuss the viscosity. So I am saying viscosity. That means it is dynamic viscosity. Okay. That is, it is dynamic viscosity. So the dynamic viscosity mu is, okay, the unit should be Newton second. Okay, it is Newton second per meter square. Sir, this is SI unit. This is SI unit. Okay, what should be the CGS unit? Okay, CGS unit, gram, centimeter, and second unit. In that case, force has the unit of dyne. Okay, dyne second per centimeter square. Okay, and this is also called as poise. So this is also called as poise. तो एब्सोल्युटली बफर हो रहा है, बिल्कुल बिल्कुल। हाँ जी, अब चेक करो, अब चेक करो, अब नहीं होगा बफर, अब नहीं हो जाएगा। ओके, so sir, one poise is, if we write down the definition of the one poise, sir, how much is the one poise? So one poise is simply equal to 10 to the power minus, okay, 10 to the power minus 1 Newton second, okay, per meter square. This Newton second per meter square is also called as Pascal second. Okay, it is also called as Pascal second. So answer will be B. Next question. Okay, next question. Next question. Okay, next question. The volumetric change of the fluid by the resistance. These are easy questions. What should I discuss? These are easy questions. So the volumetric change of the fluid caused by the resistances. So the volumetric change of the fluid caused by the resistances. What should be the answer? What should be the answer? Okay, C. Adnan is saying C is the answer. If we are defining the bulk modulus, so what is bulk modulus? What is bulk modulus? What is bulk modulus if we are defining bulk modulus? Simply we can say the bulk modulus is defined as, okay, your bulk modulus is defined as change in the pressure to the volumetric strain. So if we are writing the bulk modulus, okay, denoted by B, okay, beta, so that is equal to change in the pressure upon volumetric strain. Volumetric strain can be written as delta V by V. Absolutely correct, sir. Delta V by V. Okay. Sir, it is the resistance means here the pressure. Okay, resistance means here the pressure. So the volumetric change caused by this resistance is simply nothing but the compressibility. Okay, so 1 upon beta is K, that is compressibility. That is compressibility. Okay, that is the compressibility. Now the compressibility will be delta V, that is volumetric strain upon the change in pressure. Upon change in pressure. My important concept here, this bulk modulus is defined for hydrostatic loading. Hydrostatic loading. Sir, what is hydrostatic loading? Hydrostatic is the loading that is equal in all the directions. Okay, that act is equal in all the directions. We have the cube here. We have the cube here. Absolutely correct, sir. Okay, this cube is placed in the water. In the water, sir. From all the directions, we are getting the same pressure. We are getting the same pressure. So here we can define bulk modulus, okay, or compressibility. Okay. So the compressibility is nothing but the volume change due to the resistance. Absolutely correct. Next question. Next question. Next question. Okay, next question. Next question. Next question for you. Arshita, answer is C. What is happening? Okay, Adnan, Yasmin, provide me the answer. The property by which of the molecules of the fluid are attracted by their own is called. Okay. So the property by which of the molecules of the fluid are attracted, okay, by their own. It is saying own. Okay. It is the own attraction. So that force is called as what? Cohesion. That force is called as cohesion. So we have the two types of attraction among the particles. We have the two types of attraction among the particles. So the first attraction is cohesion. So what is the cohesion? Cohesion is the force of attraction. Okay, it is the force of attraction. It is force of attraction among same particles. Okay, among same particles. Among same particles. Okay, same particles. That is, if we have the water. Okay, if we have the water, the force of attraction among water particles will be called as the cohesion. Okay, will be called as the cohesion. Now we have the adhesion. Sir, what is adhesion? What is adhesion? Adhesion is the force of attraction. It is also the force of attraction, but between different particles. Between different particles. Okay, it is between the different particles. So we have the water, we have the air. Okay, the force of attraction among the water and air particles will be called as the cohesion. Okay, sorry, adhesion. And the cohesion is called as what? And the cohesion is called as the force of attraction among the same particles. Among the same particles. Okay, so the answer should be B. Okay, the answer should be B. Anyone, the answer should be B. Next question for you. Next question for you. Next question. These are basic questions. These are basic questions. Okay, remember these are basic questions. तो जैसे जैसे आगे बढ़ेंगे न्यूमेरिकल भी आएगा, ठीक है, और लेवल थोड़ा सा टफ आएगा. So these are the basic questions. Okay, Yasmin is saying B is the answer. Harshita, B. Anyone else? Anyone else? I think this question is asked in every examination. Nani is saying B is the answer. Anyone else? Anyone else? We have an ideal fluid. Okay, we have an ideal fluid. Sir, what should be the ideal fluid? Ideal fluid is imaginary fluid. It does not exist in the nature. Okay, ideal fluid does not exist in nature. So when the fluid does not exist in nature, that means the fluid is inviscid. Okay, inviscous fluid. Sir, what is inviscous? That is, there is no mu. Okay, mu is equal to 0. Remember the difference between the Newtonian fluid and the ideal fluid. In case of the Newtonian fluid, mu is constant. Okay, And in case of the ideal fluid, mu is 0. And also, sir, this ideal fluid is incompressible. Sir, what is incompressible? What is incompressible? In case of the incompressible fluid, okay, the temperature change, if we are changing the temperature, if we are changing the pressure, okay, these does not have effect on the density, okay, on the density of the fluid. If we have the fluid here, so we are changing the temperature, we are applying the pressure, so the density remains the constant. That means the fluid is ideal fluid. So what should be the properties of the ideal fluid? It should be in viscous and it should be incompressible. Okay, absolutely correct. It should be incompressible. Okay, next question on your screen. Mark down the question number 10. First, mark down the question number 10. Mark down the question number 10. Mark down the question number 10 first. Okay, I want 8 answers. I want 8 answers. Everybody, please provide me the answer. Okay. So, which of the following is the dimensionless? Harshita is saying answer is C. Anyone? Adnan, Yasmin, anyone? Which of the following is dimensionless? 10C. Okay. 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 So, everyone. So, which of the following is dimensionless? Anyone else? Anyone else? Okay. So, anyone else? Dimensionless. Okay. So, if we are looking for the specific gravity, if we are looking for the specific volume, okay. So, what is specific volume? What is specific volume? So, specific volume is nothing. It is 1 by specific weight. It is 1 by specific weight. And the specific weight is denoted as small w. Okay. So, what is specific weight? What is specific weight? Anyone? What is specific weight? So, the specific weight is, okay, weight of the fluid per unit volume. Remember, it is weight, not the mass. It is the weight per unit volume. Okay. So weight can be written as mass times acceleration divided by volume. And we know that mass by volume can be written as density. So rho g is the specific weight. Okay. It is not the dimensionless. If we are looking for the specific gravity, so specific gravity denoted by g is the ratio of relative terms. It is the ratio of relative terms. Okay. So it is the ratio of unit weight or mass density. It is the unit weight or mass density, okay, of the fluid to the standard fluid. So it should be what? It should be your dimensionless. It should be dimensionless. No unit for the specific gravity. Okay. The question number 11. Mark down the question number 11 now. Mark down the question number 11 quickly. Mark down the question number 11. So the fluid offers no resistance to the change of what? So fluid offers no resistance to the change of. So mark down the answer quickly. Quickly. We have the fluid. It offers no resistance to the change of. Okay. Okay. Mark down the answer. So Adnan is saying B is the answer. Anyone else? Remember, I want 9 answers. Quickly. Quickly, Harshita. Quickly. Yasmin. Everyone. Everyone. Fluid offers no resistance to the change of. No resistance to the change of. Okay. So if we are looking for the fluid, sir, we have the fluid. We have the fluid. Okay, we have water. We have water. We have the water. Sir, we have glass of water. First, this water is in glass. So we have the glass of water. Absolutely correct. Now this glass of water is filled into what? Cup. Okay, into cup. Now it becomes cup of water. It becomes cup of water. Okay. That means there is no resistance to the shape. So so fluid can take the shape of the container. Okay. So we can say cup of water. We can say glass of water. Okay. There is no resistance to the shape. Sir, there is resistance to the pressure. There is resistance to the pressure. Okay. Because this pressure P that is denoted as rho gh. Okay. That is denoted as rho gh. So the pressure is rho gh. So it depends on the density. Okay. Absolutely correct. Okay. There is the flow, resistance to the flow. Sir, that is viscosity. That is called as viscosity. Okay. That is called as viscosity. Absolutely correct. Absolutely correct. Next question on your screen. Next question. So shape is the answer for this question. Shape is the answer for this question. I'll not explain this question now. I'll not explain this question now. Adnan, I'll not explain this question now. I'll not explain this question now. The weight per unit volume. I'll not explain this question. Weight per unit volume of a liquid at standard temperature and pressure is. So weight per unit volume of a liquid at standard temperature and pressure is known as. So what is It is the weight per unit volume. Remember, it is weight per unit. Harshita is answering A. Adnan is saying answer is A. So I'll not explain this. Okay, I'll not explain this. So it is the specific weight. Absolutely correct. Specific weight. So the specific weight is denoted as small w, and it is written as weight per unit volume. Weight per unit volume. Okay, so answer should be A. Okay, answer should be A. What should be the dimensional formula for the specific weight? Remember, he will ask you. Last time it was asked in JKSSB also. So the weight is simply, we can write down the weight as force. Sir, force has the dimensional formula of MLT minus 2. Absolutely correct, sir. Okay. Divided by the volume. Volume has the dimensional formula of L cube. So I will write down the dimensional formula MLT minus 2. Okay. M L minus 2 T minus 2. Okay. Sir, this is the dimensional formula of specific weight. Okay. Absolutely correct. Next. Next. What is the rheology? Rheology is the study of. Rheology is the study of. Okay. What is the rheology? Rheology is the study of. Quickly. So rheology is the study of. Rashita is answering C. So rheology is the study of what? Adnan is answering C. So the rheology is the study of what? Okay. So rheology is the study of non-Newtonian fluids. Absolutely correct. C is the answer. Next. So these are easy questions to understand. Okay. Next. Next. Okay. Okay. First we'll discuss this question. Then after we'll go for the last one. So what is the answer for this question? Adnan is saying D is the answer. Anyone else? Remember, please mark down the question very carefully. Mark down the question very carefully. Okay, because silly mistakes are there. So you are okay. You are doing a lot of silly mistakes in the examination. For that you need practice. Okay, for that you need patience. Adnan, you need patience. Okay, you need to understand four options as well. Okay, you need to understand four options as well. Remember, this silly mistake is always in the easy questions, in the easy portion of this paper. So you need to understand four out of four options, then you should mark the answer. Okay. Okay, most of the time these silly mistakes, okay, these silly mistakes, इन्हीं से आप सेलेक्ट नहीं होते हो, ठीक है। हाँ जी, देखो न्यूटन लॉ क्या होता है। न्यूटन लॉ हमारे पास होता है, इट इज द shear stress that is equal to mu du by dy. Okay, mu du by dy. Okay, and also this for the more generalized equations, your shear stress tau can be written as, okay, mu d theta by dt. Okay, sir, what is d theta by dt? D theta by dt is nothing but the rate of change of what? But the rate of change of angular moment. Okay, sorry, angular deformation, rate of change of angular deformation. So the Newton's law relates shear stress and the rate of angular deformation, so you can go with the D. Okay, you can go with the D. So you can go with the shear stress and angular deformation. Next question. Next, mark down 16 first. First, mark down the 16. Mark down 16. Mark down the 16 question number first. Then we'll go with the 17. Mark down the 16 question number. Okay, 16 is saying B is the answer. Okay. Okay. Adnan, check yourself. Check yourself. Okay. I was repeating this. Okay, check yourself. Adnan. So last time I discussed this also. So you should need to revise the question. You should need to understand the question, and you should give the time to the question. Okay. तो ऐसा नहीं है easy question है sir, it is easy question we can go. No, it's not like that. You should first understand the question, then after you should go with the exam answers. Okay. So the first is the unit of kinematic viscosity. Kinematic viscosity is, okay, kinematic viscosity is denoted as what? It is denoted as nu. Absolutely correct. And that is dynamic viscosity by what? That is dynamic viscosity by density. Okay, absolutely correct. Dynamic viscosity by density. Absolutely correct. Okay. Sir, your kinematic viscosity has the units of meter square per second. You can calculate this meter square per second. Okay. So you'll go with the A. Sir, it has this is called as SI unit, and it has also CDS unit. In case of CDS unit, the unit of the kinematic viscosity is what Stoke is Stoke. Okay. That is Stoke. And that can be written as centimeter square per second. And remember, one Stoke, okay, is equal to 10 to the power minus 4. Absolutely correct. 10 to the power minus 4 meter square per second. Okay. Absolutely correct. So the answer should be A. Now mark down the 17 question. Mark down the 17 question. So 1 cubic feet. It is a 1 cubic feet in case of the liters. So you'll remember this question forever. 1 cubic feet. 1 cubic feet. 17 is saying answer is B. Okay. 17 for the 17 you are saying the answer is B. Okay. You'll remember this also. So what should be the answer? One cubic feet of the water is equal to 1 cubic feet of the water is equal to what should be the answer? Always remember 1 cubic feet. Okay, 1 cubic feet of the water is always equal to 28.32 liters. Okay, so remember this always. Remember this always. So you can also calculate, but okay, for the JE examination you can remember this. Okay, it is 28.32 liters. Absolutely correct. Okay, next question. Next question. Okay, these are easy questions to understand. Okay, these are easy questions to discuss. What is the answer for this question? If in a fluid the shear stress is found directly proportional to rate of angular deformation. Okay, Adnan is saying D is the answer. Quickly, Harshita, provide me the answer. I will proceed. Harshita, provide me the answer. I will proceed. Okay, I'll proceed. Okay, so we have the shear stress that is directly proportional to. Okay, that is directly proportional to rate of change of angular deformation. Okay, that law is nothing but the Newtonian law. Okay, but the Newton's law. So you will go with the D. Okay, you will go with the D. Next. Remember, remember, Adnan, I'll discuss every level. Okay, I'll discuss every type of question. I'll discuss every type of question here. Every type of question. Okay, every type of question. I'll discuss every type of question. Okay, these are theoretical questions first. These are the theoretical questions. Okay, these are the theoretical questions. The resistance to the gradual deformation by shear stress or tensile stress by a fluid is termed as. Okay, so what is the property termed as resistance of the resistance to the gradual deformation by shear stress. Okay, so okay, so I will tell you. I will discuss the Newton's law. Okay, so first, these are surface, sir. These are surface. Absolutely correct. So we are flowing the fluid. Okay, there is the flowing fluid. There is the flowing fluid. Okay, sir, this is flowing fluid. Absolutely correct. Sir, on the boundary, it has been okay. It has been discussed on the boundary. Okay, it has been found that on the boundary, the velocity is zero. The boundary of the fluid with the the velocity of the fluid with this boundary is equal to zero. Okay, here the velocity is zero. Sir, in that case, velocity is zero. Absolutely correct. That is no slip condition. No slip condition. That is the fluid at rest when it is in contact with the boundary. Sir, when we go away from this boundary, the velocity increases. The velocity increases. Velocity of the every layer increases. Okay. So if this is first layer, the velocity, let us suppose, was 1 meter per second. And in the second layer, the velocity was 2 meters per second. And in the third case, okay. In the third case, the velocity was 3 meters per second. So, sir, there is the velocity difference. 3 and 2, 3 and 2, 2 and 1. Okay, sir, when there is the velocity difference, there is the velocity gradient. This is called as velocity gradient. The change of the velocity with distance, sir, this is velocity gradient. And in that case, the velocity gradient, okay, the shear stress was discussed at directly proportional to this velocity gradient du by dy. Okay, so that was the Newton's law. That was the Newton's law. Okay, so now what is the viscosity? Viscosity is the deformation per unit. Okay, or the resistance to the flow. Resistance to the flow. Absolutely correct. Next. to avoid the correction for capillary action, we have the capillary action in manometric fluids. Okay, for measuring the minimum diameter of the tube should be. Okay, so in case of the manometer, we are using the tube to calculate the pressure. Absolutely correct, sir. Absolutely correct. So if we are avoiding the capillary, if we are avoiding the capillary action, okay, if we are avoiding the capillary action, we are taking the minimum diameter of the tube. What is the minimum diameter of the tube? We are taking the minimum diameter of the tube. What is the minimum diameter of the tube? Okay, what is the minimum diameter of the tube? Quickly. Okay. So if we have the manometer here, okay, so there is a tube in the manometer. There is the tube in the manometer. Okay. So in case of the measuring fluid, in case of the pressure measurement, absolutely correct, sir. Okay, the fluid in this container will rise up. Okay, will rise up. Absolutely correct, will rise up. Remember, if we are putting the diameter, if we are putting the diameter of this tube D less than 6, okay, if we are putting less than 6 mm, sir, there will be capillary action. This water will flow by the capillary action. Okay, this water will flow by the capillary action. Okay, this water will not flow then by the pressure. Okay, by the pressure difference. Okay, this water will flow by the capillary action. In that case, you should put the diameter of the tube greater than 6 mm by the by the pressure. Okay, by the pressure. So the diameter should be 6 mm. Okay, diameter should be 6 mm. Now the question number 21, 21 and 22. Question number 21 and 22. Question number 21 and 22. Adnan, are you enjoying the class? Are you enjoying the class? Adnan, please provide me the feedback. Are you enjoying the class? Okay, anyone? Harshita. Harshita is saying answer is C for this question. Pascal second is the unit of. Okay, Pascal second is the unit of. Okay. Okay, so every day there will be this class. Okay, this practice session class. You can check my other channel also. So there is also a lot of practice sessions. Okay, there is also ESC discussions. Okay, so you can go through that also. So the Pascal second is the unit of dynamic viscosity. Okay, dynamic viscosity. Absolutely correct. Dynamic viscosity. And what's the answer for this question number 22? What is the correct dimension for surface tension? Remember, everything related to surface tension is discussed in the questions. Okay, everything related to surface tension is discussed in these questions. Okay, okay. Absolutely correct. So the surface tension has the units of, okay, it has the units of Newton per meter length, or it has the force, it has the energy per unit area. So energy has the unit of joule and the area has the meter square. So it is the joule per meter square. So you can go with the B. Joule per meter square, you can go with the B. Okay, absolutely correct. Next. So it is curve A, curve A. It is curve A. So curve A is representing what? Curve A is representing what? Quickly. Curve A is representing what? So which type of fluid is represented by curve A? It is curve A. It is curve A. The question here says identify the fluid which is represented by curve A. Okay, curve A is represented by curve A. So what is the answer? Curve A. So which type of fluid is represented by curve A? Adnan is saying answer is B. Anyone else? Harshita, Adnan, quickly. These are theoretical questions. So they'll be discussed. Okay, these are theoretical questions. You will remember them also. Okay. So which type of fluid is represented by curve A? Okay, I will write down. So the curve parallel to this x-axis or deformation. Okay, that curve is simply nothing but the ideal fluid. Okay, that is ideal fluid. Okay, that is ideal fluid. And we have the second. We have the second curve for which B is 0. Absolutely correct, sir. B is 0. And we have n is greater than 1, n is greater than 1, and B is 0. In that case, the liquid is dilatant. Okay, it is dilatant. We have the third curve. For third curve, B is 0, intercept is 0, and n is 1. In that case, the curve is simply called as Newtonian. To 0, that curve is called as the pseudoplastic. Okay, and for the A curve, we are having the straight line graph. B is not equal to 0, B has some value, and n is 1. In that case, it will be ideal being plastic, and the answer will be D. Okay, it will be ideal being plastic fluid. So the answer should be okay. Answer should be D. Okay, so curve A is this. This is curve A. So you can go with the ideal Bingham plastic flow. Okay, okay. Shall we stop the discussion? Shall we stop the discussion? Anyone? Or continue? Shall we stop or continue? Okay, okay, okay. So, so we'll continue this session. Okay, every day. Okay, and also we'll discuss the timing also. We'll discuss the timing also. Okay. So thank you so much. Okay, Adnan, Adnan, I'm busy. Okay, I'm currently busy. I have another class. Okay, I have another class. So this session was scheduled for the 40 minutes on. Okay, so thank you so much. So we'll put this session continue. Okay, on this channel. You should subscribe this channel also. Okay, thank you so much. Thank you so much, everyone. Thank you so much. Actually, this is English channel. I'm providing the content in English, so I'm using. Okay, sometimes I'm using here Hindi also. Okay, okay. Next step, it is chapter wise. Okay, this was the first chapter. There are almost 20, I think 20 to 30 questions more to discuss. Okay, more to discuss for for this chapter. Okay, so first you will property of the fluid, then you will go with the then the second chapter is the forces on the submerged bodies. So these two topics will be discussed in the next class. Okay, so don't worry, don't worry. Okay. Okay, thank you so much. Thank you everyone for joining the class. Thank you so much.